This is lesson 2.1, Classifying Polynomials. Everything we learn in this section, you have learned in Math 9, so I'm going to go pretty quickly, but if you need extra help or clarification, please let me know. So a bunch of definitions to go over for Math 9 when dealing with polynomials. A term is either a number on its own, a variable on its own, or a product of numbers and variables. So I listed a bunch of examples there. You could have 7, that's a term, x is a term, and xyz is a term. The difference between the coefficient and a constant is that a coefficient is the number in front of a variable. It's multiplied by the variable. And a constant is just a number on its own entirely. It has nothing to do with the variable. So in the term 5x, the coefficient is 5. But a constant on its own would be like 4 or -3. A polynomial, which we'll work with for this whole chapter, is a term or a sum of terms. And there's two restrictions about what makes a polynomial. One, all of the variables have to have whole number exponents, so they can't have fractions as their exponents. And two, the variables have to only appear in the numerator. This means it has to have positive exponents. So based on what we learned in chapter 1, if you have a negative exponent, it means it's in the denominator of the fraction. So that's not allowed. So I've listed examples of things that are considered polynomials, and then those that are not considered polynomials. So x to the 1/2 is not a polynomial because it has a fractional exponent or an exponent that is not a whole number. And then 2x to the -3 also is not a polynomial because it has a negative exponent. In other words, the variable would appear in the denominator. There are 3 classifications of polynomials that we use based on how many terms there are. Monomial has 1 term, binomial has 2 terms, trinomial has 3 terms. If a polynomial has more than 3 terms, just call it a polynomial. But most of the time, we'll be working with mon, bi, or trinomials. I have some examples listed. Next, this is something students often get confused with: degree. Degree of a term, degree of a polynomial. To find the degree of a term, you just add up all the exponents on the variables, only on the variables, not on any coefficients or constants. So I have some examples here. For 3x cubed y4z, to get the degree, you just add up all the exponents on the variable. So 3 plus 4 plus 1. Don't forget the invisible 1 exponent on z. Although there's not a 1 written there, it's to the power of 1. So don't forget it. Next example, a, b, c. Technically, there's no exponents visible, but they each have an exponent 1. So the degree of this term would be 3. And the degree of a constant or a number on its own is just 0 because there's no variables. Once you understand how to find the degree of a term, you can find the degree of a polynomial because you just find the degree of each term in the polynomial and pick the biggest one. So I listed a big polynomial here. The degree of this is going to be 7 because I just found the degree of each individual term and picked the biggest one. The degree of this is 4, the degree of this is 7, this one is 1, this one is 0. 7 is the biggest one. Next, we have like terms. These are terms with the same variable and the same exponent on the variable. So 2x and 3x are like terms. 4x cubed and -10x cubed are also like terms. Other examples would be any constants. Those are like terms with each other. So 1, 2, 7. But reminder, they have to have the same variable and same exponent on the variable. So like 2x and 2y are not like terms because they have different variables. We can collect or combine our like terms by adding the coefficients together. So 2x and 3x gets combined to give you 5x. You have 5 x's in total. 4x cubed and -10x cubed would be -6x cubed because we combined those coefficients. And then an easy one, 7 and 3, of course, just becomes 10. Lastly, how to evaluate a polynomial at a given value. You just substitute that number into the variable and solve. And we'll do an example below. So bringing all of this recap together, we want to identify the above vocabulary on this polynomial, then simplify it by collecting like terms and evaluate it at x equals 2 and y equals 1. So first, I'll list all the terms. We have 4 terms here in total, which I've listed here, whatever is separated by the addition or subtraction. What I've underlined in green are the coefficients because those are the numbers in front of variables. And then in red is our constant. That's the number on its own. This is just called a polynomial because there are 4 terms and it's above 3. So we just call it a polynomial. For the term degrees, I listed each term and calculated the degree of each one. We've got 4, 2, 0, and 2. That means the polynomial degree is 4 because that's the biggest number of all of those. The like terms, 2x squared and 5x squared, are the only like terms in this polynomial. And then to simplify by collecting them, that would just give us the total of 7x squared. So this is now a trinomial once we've combined those two terms together. Lastly, we want to evaluate at x equals 2 and y equals 1. So you just take the polynomial, replace x with 2, replace y with 1, which I've done here. Then you just calculate. Make sure when you're evaluating, substitute it in with brackets so that you get the correct sign if you have positive or negative. The last part of today is reviewing multiplication of polynomials. Again, you would have done this in grade 9. Multiplying a monomial by a monomial, you're just going to multiply the coefficients together and multiply the variables together. This uses what we just talked about in chapter 1 as well. If you're multiplying variables together and they're the same variable, then they have the same base, so you just add the exponents together. So this example here, the coefficients that multiply together to give you 8, that the x's become x to the 5, and the y is on its own. Lastly, multiplying a monomial by a binomial, you're going to use the distributive property. So whatever's on the outside gets multiplied into all the terms in the brackets. So in this example, we've got a monomial times a trinomial. So you can write it out as whatever's on the outside, 3x, times each of the terms on the inside. And then you just have a bunch of monomial multiplication, which we know how to do. Some examples. Easy monomial multiplication here. The coefficient becomes negative 12. The a's combine to give us a to the 3, and the b's become b to the 4. That's all you have to do. We've got 3 monomials here, but same idea. So the coefficients will all multiply together, and then we can combine our variables. So for a, we'll add the 4, the 3, and the 1. For b, we'll add 3, 2, and 1. You don't have to write this first step here. You can go right to the answer, but I wanted to show my work a bit more in case you were confused. And then some distributive property examples. I draw these arrows to represent whatever's on the outside is multiplying into the brackets. Again, you don't have to do this first step here. You can go right to this step, but I like writing it out, especially when they get more complex, so you know exactly what multiplication you're doing. Whatever's on the outside times the first term, whatever's on the outside times the second term. Then you do your multiplication like normal. And then the last one here, a bit longer, but same idea. Whatever's on the outside times the first term, whatever's on the outside times the second term. And then I ran out of some space here, but I put it underneath for the last term. Then we bring it all together. When you're doing these multiplications, make sure that you always collect like terms to fully simplify your answer. In this case, there aren't any like terms to collect. And just be really careful with the sign. So especially when there's a negative on the outside, make sure that negative is applying to every single thing in the brackets. So that is our recap about kind of our introduction to polynomials, the different vocabulary, and how to multiply them.